Okay, lesson 1 in unit 3. It's called hide and seek, and you'll figure out why in a second, hopefully. We're going back old school here. If f of x equals x squared, find f prime of 3 using this limit definition of a derivative. Okay, so if you recall, a is your specific point. So for every place you see an a, you're going to be filling in 3, because that's what we want, the derivative at 3. So f prime of 3 is equal to the limit as x approaches 3, because that's my specific point. Now my fraction, it says f of x. Well, what is f of x? X squared. So I'm going to have x squared minus, well, remember, we're replacing all the a's with 3's, so this is really saying f of 3, which means you need 3 squared, which is 9. Over, on the bottom you have x minus, and what's a? 3. Okay, so now ignore what this represents and just look at this as a limit question. If I sub in 3, I'm going to get 9 minus 9. Oh, look at that, I get a 0 over 0, which means what do you have to do? Factor, reduce, plug in. Now you could do L'Hopital's, but I don't know, factoring and reducing might not take that long. Factor, reduce, plug in again, and you end up with f prime of 3 is equal to, well, let's see here, 3 plus 3 is 6. Okay, that's not so bad, but I don't want to do all that work, so we're going to skip all that work and find a way around it. I don't know why I have this on here twice, so just cross that out. We're just going to focus right here. If you'll notice, what you are being given here is the exact same thing that we have up here. The limit as x approaches 3 of x squared minus 9 over x minus 3. Now we know from up here that the answer is 6. But I want to know, if I didn't have this and I was just given this, can I get to an answer of 6 in a quicker way? Because I think we all realize this. We have to get to the right answer, but we have to get there quickly. So what you're looking at, you're trying to match this limit up to the limit definition. And if you'll notice, looking at this formula up here, f of x is sitting right here in the fraction. So if you come down here, f of x is sitting right here. So what you can do is, if you look at this limit, you can say, hey, guess what? I know what f of x is. And I know that this isn't any old limit. This is a limit that is specifically asking me for a derivative. And I know that they want the derivative at a specific point. Well, what's that specific point? 3. So I can just say, oh, well, f prime of 3 is 2 times 3, so the answer is 6. And I don't actually have to calculate the whole limit. So what your goal is with these questions is to match the limit up to the definition. You have to find the function. You have to find f of x. Hence hide and seek. It's hiding. Can you find it? Find f of x within the limit, pull it out, take the derivative, sub in your point, get your answer. And then you're done without doing any of the limit work. So now, if you look at this next example, we all know that according to the limit definition, the function is sitting right on top in front of the fraction. So your function is right there at the beginning of the fraction. So if you look at this, what's the function? It's x to the third. It's right there in front. So I know that this limit is really saying that f of x is x to the third. This limit wants me to find the derivative, and they want me to sub in a specific point. Well, what's my specific point here? 4. So I have 3 times 4 squared. So what's that? 48. So that's my final answer, and I didn't have to do all the factoring, which would have been SOAP. I didn't have to do SOAP and then cancel and plug in again. I just had to find the function, pull it out, take a derivative, sub in. Okay? Now, as you know, we have 3 different limit definitions of a derivative. They're not all going to be that easy. If you look at those 3, they're all on top, on the front board. This is the one, I'm going to call this 1, and this is your purple. That's the purple definition on the board. This is the second one, which is the blue definition on the board. And this is the third one, which is the pink definition on the board. Now what you need to realize, if you look at the first one, that's the one we just did on the previous page, notice that f of x is my function that's right there in it. It's not hiding, it's sitting right there. It's at the front of the fraction. If you look over here, do you see f of x anywhere in this fraction? No. So we have to find it, okay? So when you look at this, when you see that you have a number, now look at a is your specific value, and that's what you're trying to find, the derivative at a. When you see the number plus h, picture that as an x, and you'll find your function. And I'll show you an example, so don't worry. And then if you look at choice 3, option 3, this is just a derivative. This is not a derivative at a specific point, okay? And notice that f of x is right here. It's behind the subtraction sign, so you have to watch out for that. And again, you'll see examples, okay? So when you're looking at this, evaluate the limit. Okay, I don't really want to, so I'm going to try to match it up and see if I can find a shortcut. Well, if you look at this, as h approaches 0, well, that means it has to be one of these two. So then you want to look. Do you have a number plus h, or do you have x plus h in the parentheses? Well, look, it's 1 plus h. So that means this matches up with that second definition, okay? So now watch this. If you picture wherever you have a number plus h, picture that as an x. There's your function right there. 2x to the third. So it's not as obvious as the previous page, but it's still there, okay? Now, I know that this is a special limit that actually wants the derivative, so I can say the derivative is 6x squared. But this one wants the derivative at a specific point. What's the specific point? Well, you need to look and see, well, what is the number that's getting added to the h, because that's your specific point. And in this case, it's a 1. So you want f prime of 1. And that's your answer. And again, the other option that I have is to take the 1 plus h, cube it. So I would have to do 1 plus h, 1 plus h, 1 plus h. I would have to multiply all that out, distribute a 2, cancel things out, factor out an h to cancel out my denominator, then get my answer. So this is going to be a lot faster. It's going to be a lot faster if you can just pull out the function, derive it, plug in. Okay? Let's look at the second example. All right, 4x plus h plus 3 minus 4x plus 3. So the first thing I notice, because I want to try to match it up with one of the 3 on top, it's a limit as h approaches 0. So that right there tells me it has to be one of 2 or 3. Okay? The limit as h approaches 0 means I'm using blue or pink. So now what I want to look at is inside the limit, do you have a number plus h? That would be here. Or do you have an x plus h? That would be here. Well, in the parentheses, I have x plus h. So this means this matches up with the limit number 3. If you go back to this, where is f of x? It's after the subtraction sign. So when you look at this, you have to think that this is really, you are subtracting the quantity of 4x plus 3. See, what they did is they distributed that negative, so it looks like it's negative 4x minus 3, but really your function is what comes after the subtraction sign, so that's just a 4x plus 3. Okay? So it's a little tricky, but it's there. The other option that you have is to do what we did above. Where you see those parentheses, picture that as an x. If you see these parentheses right here, just picture it, instead of an x plus h, pretend that's just an x. And then you see that you have 4x plus 3. So that's right there. And that matches what's after the subtraction sign, so that you actually have two ways of pulling out that function. The derivative is 4. And this definition is not asking for the derivative at a point. You don't have to do that. This just wants the derivative anywhere. So that's a 4. As opposed to the previous example, they wanted the derivative at 1. Okay. Look at 3. It says the limit as x approaches 2. Love this, because when you look up top, the only limit that has an x in it is the first one. These all have h's approaching 0. So that means I have to use that first limit definition, and that tells me that my function is right there at the beginning of the fraction. So I do think these are kind of the easiest. So right here, my function is sitting right up there in front. 5x squared. What's the derivative? 10x. What's the specific point you're subbing in? That's right here. Whatever x is approaching, that's your specific point. You want to sub in a 2. And I'm done. No factoring, canceling, reducing, none of that. Example 4. H approaches 0. So that means option 2 or 3. And then I look in my parentheses. Since I have a number plus h, it's going to be option 2, the blue limit. So every place I see a parentheses, wherever I see the 2 plus h, I picture that as my x, and that tells me exactly what my limit is, or excuse me, what my function is. 3x squared minus x. So that's my function over here. So then I take the derivative. Now, this is a derivative at a specific point. So you need to think about, what is the specific point? Well, you want to look at what number was getting added to the h. So don't make your x too dark here. You want to see that number. I had a 2 plus h and a 2 plus h. That should always match. So this really wants me to sub in a 2. This big old limit is just asking me for the derivative at 2. So if you can find the function, there's your shortcut. And you're done. Okay, if you flip the page, you can now see some super AP questions that they ask on this. And notice, this is what it looks like. They don't give you much here. They just say, okay, the limit as h approaches 0. They're not telling you anything else. That's it. Calculate the limit. Okay, so you got to do whatever you have to do to get that limit. Well, I know that the limit as h approaches 0 is a special derivative. So that's where I want to find, can I find f of x so that I can take its derivative? Well, I see that I have an x plus h here. So I can picture that as an x, and I can look at this as cotan of 3x. Or you can look at what comes after the subtraction sign. Now remember, it's after the subtraction sign is your f of x. So there's two different places you can look, and that's where you can find your function, cotan of 3x. Well, this limit really represents the derivative. Well, the derivative of cotan is negative cosecant squared of 3x, chain rule, times 3. So now this is asking for the derivative at a specific point, or just the derivative? Well, because it's x plus h, it's just the derivative. That's my answer. Hopefully we can find it. It looks like I have a negative 3 out in front, so I'm looking, it's not B. Oh, it looks like it's D. There you go. Okay. 2 more questions. If it were me, I'd probably hit pause and try this question on my own and then hit play so I can check my work, but you know, that's just me. You guys can do whatever you want. If I look at this, the slope of a curve at a point xy is defined by this. Well, look at that. Which of the following is the equation of the tangent line? Oh my gosh, could this be a better question? At x equals 1. They're telling you a lot of information in that sentence if you can interpret that. The slope of a curve. Well, what does that really mean? The slope of a curve. That's your derivative. So they're telling me that the derivative is defined as that limit. Okay? So I need the equation of my tangent line at 1. So the equation of my tangent line, y minus f of x equals f prime of x times x minus x1. And they told me that x is 1. Oh, this is just fabulous. So now if I look up here, I need to be able to find the function. I want to somehow find out what is f of x. It's hidden in that limit. In this problem, I have to pull that out so that I can evaluate this right here. There's no other way for me to do this, okay? So again, every place I see an x plus h, I can picture that as an x if I want. So this right here, I can picture that as an x, and this right here, I can picture that as an x. Now look at your function. It pops right out. Hopefully it pops right out at you. X to the third plus x squared. Now look at this. The function is what's after the subtraction sign. So you need to think that that was negative x to the third plus x squared. So I don't know where it's easier to see it, because down, if you're looking at the back of the fraction, you have to worry about that negative. So you have to factor that out so you can find your function. Either way, I know that the function is x to the third plus x squared. So then I can find f of 1 and get 2. So now I know I've got y minus 2 equals. Okay, well now I need the derivative. 3x squared plus 2x. And I need to sub in a 1. 3 plus 2, so that's a 5. Now that choice isn't there. If I look at this, all of my choices are y equals form, so I just need to solve for y. And I've got my answer. Oh, that was a fun one. I like that one. Okay, last question. Find the limit as x approaches infinity. Guess what? This has nothing to do with the whole lesson we've done today. This is just a limit question. And notice, this is what could happen on the AP test. They could have a regular limit to infinity mixed in with a fancy limit that represents a derivative. So we have to recognize the difference. When you see that h approaching 0, that's a big clue. That right there, that should tell you this has something to do with a derivative. The limit as x approaches infinity, well heck, we've been doing that for 2 years. So if I'm going to infinity, I want to focus on the highest degrees, and my limit is 1/4. So again, what the AP test can do is just mix all these limits together, and you have to recognize, is this a limit that I'm actually calculating out, or is this a limit that really is asking me about a derivative? Okay, and that's it.